Here we're going to take a look at numbers 4 through 7. We're asked to determine if the sequence is arithmetic, geometric, or neither. Remember, an arithmetic sequence grows by constant addition. If a sequence is geometric, it goes through constant multiplication. And if we don't see either of those, then it would be classified as neither. So number 4, we've got this fun one. 2.786, 27.86, and then 278.6, and then the next one is 2,786, ... So I'm noticing that 2786, you see that too, I'm sure. Well, what's happening is the decimal, which was here, is now between 7 and 8, and now it's between 8 and 6, and now it's at the very end. There's nothing you can add between each term. If you're suspicious that it could be arithmetic, what do you add to 2 to get 27? 25. Would you add 25 to 27 to get 278? And the answer is no. No way this could be arithmetic. So let's try to see if it's geometric. Well, if you take any term divided by its previous term, 27.86 divided by 2.786, you're going to get 10. If you take this one divided by that one, you're going to get 10. If you take this one divided by that one, you're going to get 10, which is telling us it's geometric. That's what's going on in number 4. And our reasoning is that there's a common ratio of 10. So it's geometric, and this is why. So let's take a look at number 5. Number 5, we have 86, 71, 56, 41, ... Okay, if it's multiplication, nothing seems obvious to me. It's getting smaller, so it would be some fractional value. Maybe it's that, but I'm thinking because it ends 86 ends in a 6, 71 ends in a 1, 56 ends in a 6, 41 ends in a 1. I'm thinking it's probably something's being subtracted. So what I have to do is take any term and subtract its previous term, and then double check it with some other ones. So if I do 41 minus 56, well, first and foremost, we know the answer is going to be negative, but to get the value of that, we have to switch it so it says 56 minus 41, which is going to be 15. So when we subtract them, we see that 15 is subtracted from 56 to get 41. Well, let's try with 56 to 71. So we would have to do 56 minus 71, which we're subtracting a bigger number. We know it has to be negative, but to subtract, we got to do the 71 minus 56. We'll borrow 1 from the 7 to make it a 6. That'll be 11. 11 minus 6 is 5. 6 minus 5 is 1. Hey, we're getting negative 15 again. So as we go from here to here, we subtract 15. Now let's just see if that's true. If I add 15 onto 71, would I get 86? And the answer is yes. So to go from 86 to 71, I'm subtracting 15. So this one, we can say that we see subtracting 15, subtracting 15, subtracting 15. This is definitely arithmetic. Arithmetic. And the reason is there's a constant or common ratio, or a common difference, or a constant difference, either way you want to say it, of negative or of 15. Since we're declining, since the sequence is going down in value, it's going to be a common difference of negative 15. If it's growing, then that's when that would be positive. So there's our reasoning for number 5. Let's take a look at numbers 6 and 7 real quick. So number 6, yes, is 4, negative 10, 16, negative 28. So I see it flipping between positive and negative, positive, negative. there's nothing you can add to something that would make it go from positive to negative every single time. So if this is anything, it has to be geometric. So to check and see if it's geometric, I'm going to take a term and divide by its previous term. So negative 10, I'm going to divide it by 4, which is going to give me negative 5 over 2 when I eliminate a common factor of 2. It's okay if you used a calculator and you did the division to get negative 2.5. Now, let's see if we take 16 and we divide it by negative 10, do we get that same amount? 16 divided by negative 10 is going to be a negative. 10 and 16 are both divisible by 2. When I take a 2 out, I get a 5. When I take a 2 out, I get an 8. Negative 8 fifths. If you did a calculator, you'd have negative 1.6 is what you would get. Are those the same? No. So this one is neither. And what you could say is there's no common ratio or difference for your reasoning. Again, if you tried to see if there's a common difference, you would just take negative 10 and subtract 4, which is negative 14. Then you could check, if I add negative 14 to negative 10, if I add negative 14, do I get 16? And the answer is no. So there's proof enough for your no common difference. So now let's take a look at number 7. Number 7 has us take a look at 112, negative 28, and 7 and negative 7/4. All right, so again, I'm seeing that fluctuation. There's no way it's arithmetic. So to check and see if it's geometric, what I'm going to do is take a term and divide by its previous term. So if I take 7 and I divide by negative 28, 7 goes into 7 once, 7 goes into negative 28 4 times, so that'll be negative 1/4. Here's another option we have. Instead of taking negative 28 and dividing it by 112, because that doesn't look too fun, does it? What we could do is check to see if we take any term, if we take that 112 and we multiply it by negative 1/4, do we get negative 28? So let's see. You could use your calculator. You could use your calculator on your phone. So, calculator right there. Let's do 112, and let's multiply it by 0.25, and it's negative, 0.25 being 1/4. And hey, look at what we get. We get negative 28, which is what this is. If we take that negative 28, which is right there in my screen, and I multiply it by 0.25, that's negative, I'm going to get that 7. And if I take 7 and I multiply by negative 1/4, I think you can see that we're going to get negative 7/4. So this one is clearly geometric, and the reason is that there's a constant ratio of negative 1/4. There you have it.